Now here the question is, we are given this function fx, which is greatest in a function of x plus square root of fractional part of x, and we need to find its continuity and differentiability at all integer points. Now say we are going to find its continuity and differentiability at n. Now f n positive, it will be this limit x tends to n positive, get a function of x plus square root of fraction part of x. Now we let x as n plus h, so it will be this limit h tends to 0 positive, greatest near function of n plus h plus square root of fractional part of n plus h. Now get a function of n plus h is simply n, so it will be n plus, and then we know that fractional part of n plus x is fractional part of x if n is an integer. So it will be this under root of fractional part of h, and when h tends to 0 positive, fraction part of h is simply h. So it will be this limit h tends to 0 positive n plus under root h, and if you put h as 0, it will be n. So left hand limit at n, it is n, and if we find its left hand limit, it will be this limit x tends to n negative, greatest function of x plus under root of fraction part of x. Now we let x as n minus h. Now we can write this as limit h tends to 0 positive, greatest function of n minus h plus under root of fractional part of n minus h. Now this is limit h tends to 0 positive. Now greater function of n minus h is n minus 1 plus, and this is fraction part of minus h, and fraction part of minus h is 1 minus h. So it will be this limit h tends to 0 positive n minus 1 plus under root of 1 minus h. If we put h as 0, we'll get this as n minus 1 plus 1, which is n. Now if we find value at n, fn will be get a function of n plus under root of fraction part of n. Now fraction part of n is 0, and get a function of n is simply n. So in this case, fn negative is equal to fn positive, and they'll be equal to fn. So this function is continuous for all integers. Now we'll find its differentiability. Now if we find f dash n positive, it will be this limit h tends to 0. Now f n plus h will be greatest in the function of n plus h plus under root of fractional part of n plus h minus n upon h. Now this is limit h tends to 0 positive. Now this is n, and n minus n will cancel out, and this is under root of fractional part of h upon h, which is limit h tends to 0 positive. Now under root h upon h, which is 1 by under root h, and as h tends to 0, it approaches infinity. That means this function is not differentiable at integer points. So this function is continuous for all integer points and not differentiable at all integer points. So answer is A and D. Now perhaps easiest way to solve this question is using graphs. So what we'll do is we'll draw the graph of fx equals greatest in function of x plus under root of fraction part of x. Now we'll start with this graph, y equals under root of fractional part of x. Now we know that fractional part of x, it is a periodic function whose period is 1. So what I will do is I'll draw the graph of y equals under root of fraction part of x between 0 and 1. And we know that between 0 and 1, fractional part of x is simply x. So that means we just have to draw the graph of y equals under root x. That's the graph of y equals under root of fraction part of x. This is 0, 1, 2, 3, minus 1, minus 2, and this value is 1. Now we have to draw the graph of y equals greatest linear function of x plus under root of fraction part of x. Now if x lies between 0 and 1, then in that case greater function of x will be 0. So it will just be this graph, which is same as y is equal to fraction part of x. Now when x lies between 1 and 2, greater function of x will be 1. So it will be 1 plus under root of fraction part of x. So this fraction part x graph, it gets shifted by 1 unit along positive y-axis. Now previously it is between 0 and 1. Now it will be between 1 and 2. So it will connect right here and it will go from 1 to 2. Between 2 and 3, greater function of x will be 2 and then 2 plus under root of fraction part of x. So this graph will be shifted 2 units upward. So from 0 to 1, now it will be from 2 to 3. So this is how this graph will be connected. So if we keep joining these graphs, we'll get this graph, and that is the graph of y equals greater function of x plus under root of fraction part of x. Now clearly this function is continuous at all integer points and it is not differentiable at all the integer points. So again this answer is A and D. So we have solved this question much easily and quicker using graphs. Now here the question is, we are given this function f which is defined from a to b and its codomain is from 1 to infinite. Be a continuous function and gx is defined in this way. Now we need to find if gx is continuous or differentiable at a and b. Now if we take g a negative when x is less than a, this value is 0, and g a positive, it will be this integral from a to a ft dt, which again is 0, and it will also be equal to this ga. So this gx is continuous at x equal to a, and at b this g b negative, and since there is an equality sign, it will also be equal to gb, and it will be this integral from a to b ft dt, and gb positive, it will be this integral from a to b ft dt. That means this function gx, it is continuous at x equal to a and x equals b. Now we have to find its differentiability. So what we'll do is we'll write g dash x. Now this g dash x, it will be 0 if x is less than a, and it will be equal to fx when x lies between a and b, and it will be 0 when x is greater than b. Now clearly g dash a negative, it is 0. Now what about g dash a positive? Now g dash a positive will be equal to fa, and codomain of fx is from 1 to infinite. That means this fa is always greater than or equal to 1. That means g dash a negative cannot be equal to g dash a positive. So it is not differentiable at x equals a. And the same way we'll find g dash b negative. Now g dash b negative is fb, and g dash b positive is 0. Again fb, it is greater than or equal to 1. So it is not differentiable at x equal to b also. So answer to this question is x is continuous but not differentiable at a, and continuous but not differentiable at b. That means options A and C. Now in the questions we are given two functions, fx which is mod of x plus 1 and gx which is x square plus 1, and we have defined hx as maximum of fx gx if x is less than or equal to 0 and minimum of f and g if x is greater than 0. Now we'll solve this question using graphs. Now we'll draw the graph of fx and gx. Now fx is mod x plus 1. That means we have to take the graph of mod x and shift it 1 unit along y-axis. So we'll take the graph of mod x and we'll shift it 1 unit along y-axis. So that's the graph of y equals mod x plus 1. Now this branch is x plus 1 and this is minus x plus 1. and then we'll draw the graph of Gx equals x square plus 1. Now, if we equate them, then we can write x square plus 1 equals mod x plus 1. From here we'll get mod x equals 0 and mod of x equals 1. So these two graphs, they'll intersect at 0 and plus minus 1. So if we draw the graph of Gx, it'll be basically this graph. Now we look for hx. Now hx is maximum of fx and gx if x is less than or equal to 0. So in this interval, whichever is higher, that's our hx. So we'll choose this graph and then we'll choose this graph. And this point is minus 1 and this point is plus 1. Now when x is greater than 0, we need to find minimum. So here minimum is this graph and it is this graph. So this function is continuous in x belongs to R, but it is not differentiable at x equals minus 1, 0 and plus 1. So number of points at which hx is not differentiable is simply 3. Now here we are given 4 functions f1, f2, f3 and f4, and we have to find this matching. Now first one is f4x. Now we are given that f4x is f2 f1x if x is less than 0, and it is f2 f1x minus 1 if x is greater than or equal to 0. Now what we'll do is we'll draw the graph of f1x. When x is less than 0, it is mod x. That means it'll be this minus x, and when x is greater than 0, it is e to the power x. Not included here and included here. Now if you look at f1x, f1x is always greater than 0. So this function, when x is less than 0, definition is minus x and it'll go to x square. So it'll be this x square, and when x is greater than or equal to 0, this definition is e to the power x, and again it'll go to x square. So it'll be this e to the power 2x, and then we have this minus 1. Now if we draw the graph of f4x, when x is less than 0, this is x square, and then we have e to the power 2x minus 1, which is this graph. So if you look at this p, it is onto but not 1, 1. Codomain of f2 is from 0 to infinite, and range of this function is from 0 to infinite. So this first one is correct. So p, it matches with 1. It is neither continuous nor 1, 1, not true. Differentiable but not 1, 1. So if we look at differentiability, then here derivative is 2x and here derivative is 2 into e to the power x. Left hand derivative 0, right hand derivative 2. So it is not differentiable. And d is continuous and 1, 1. So p is only mapped with 1. Now we look at f3. f3 is this function, sin x and x. Now we draw the graph of f3. When x is less than 0, this is sin x. And when x is greater than 0, it is this x. Now range of f3 is 2. So it is not onto. So this option A is incorrect. It is neither continuous nor 1, 1. Wrong. Now we have to check its differentiability. Left hand derivative is cos x and cos 0 is 1. Right hand derivative is 1. So it is differentiable. So it will be this differentiable but not 1, 1. So this q, it matches with 3. Now f2 OF1, basically it is this graph except for this minus 1. So if we draw this graph, it will be x square when x is less than 0, not included, and then here will be this e to the power 2x. So that is the graph of f of fx. This is not onto. It is neither continuous nor 1, 1. So that means this 2 is true. So for this R, it'll be this 2, differentiable but not 1, not true, continuous and 1, not true. And finally, we have this F2. Now this F2 is x square when x lies between 0 to infinite. So it is this function. Now this is continuous and 1, 1. And that's your option 4. So this S, it matches with 4. So it is 1, 3, 2, 4. And that's your option D. Now it says G is a differentiable function with G0 equals 0, G dash 0 as 0, and G dash 1 unequal to 0. Now we have defined this fx as x upon mod x gx when x is unequal to 0. So we'll split this definition in 3 parts. When x is less than 0, x upon mod x is minus 1. So it will be simply minus gx. It is 0 for x equals 0, and it will be this gx when x is greater than 0. So that's your function fx. And we are given hx as e to the power mod x. Now which of the following is or are true? Now if we look at this fx, then f0 negative is minus g0 negative, which is 0, and f0 positive, it is g0 positive, and that is 0 since gx is continuous at x equal to 0 and f0 is equal to 0. That means fx is a continuous function. If we find f dash x will be minus g dash x when x is less than 0, and will be g dash x when x is greater than 0. Now if we look at f dash 0 negative, it will be minus g dash 0, which is 0, and f dash 0 positive, it will be g dash 0, which again is 0. That means this function is differentiable at x equals 0. So this option A, it is correct. Now h is differentiable at x equals 0. Now if we look at this hx is basically e to the power minus x when x is less than 0, and e to the power x when x is greater than or equal to 0. Now we differentiate this. H dash x will be minus e to the power minus x when x is less than 0, and will be e to the power x when x is greater than 0. Now h dash 0 negative, it will be minus e to the power 0, which is minus 1, and h dash 0 positive, it will be this e to the power 0 plus 1. So hx is not differentiable at x equal to 0. Now we look at h of fx, it will be simply e to the power mod of fx, and it will be this e to the power mod of x upon mod x into gx. Now since we have this mod sign, so mod x upon mod x will cancel, so it will be equal to e to the power mod of gx when x is unequal to 0, and it will be equal to e to the power 0 1 when x is equal to 0. So that is the definition of h of fx. Now we have to find its differentiability at x equals to 0. Now we differentiate this, we can write d by dx of h of fx will be e to the power then mod of gx into mod of gx upon gx into g dash x. Now at x equal to 0, this g dash 0, it will be 0, and this value will be either plus 1 or minus 1. That means both left hand derivative and right hand derivative, they'll exist. So h of fx will be differentiable at x equals to 0. That means this option D is correct. Now what about f of hx? Now f of hx will be e to the power mod x upon mod of e to the power mod x into g into e to the power mod x when e to the power mod x, it is unequal to 0, and this is true for all x belongs to R. So that is the only definition that we have. So here this will cancel. So f of hx is g into e to the power mod x, which we can write as g into e to the power minus x when x is less than 0, and is g e to the power plus x when x is greater than or equal to 0. Now we differentiate this. It'll be this g dash e to the power minus x, e to the power minus x into minus 1, and here it will be g dash e to the power x into e to the power x. Now if we look at its left hand derivative, if we put x as 0, we'll get this as g dash 1 and then minus, and its right hand derivative will be simply g dash 1. And the question, it is given that g dash 1 is unequal to 0, therefore this left hand derivative is not equal to right hand derivative. That means this f of hx is not differentiable at x equal to 0. So the only correct options are A and B. Now here the question is, we're given this function fx, which is defined by this a cos mod of x cube minus x plus b mod x into sine mod of x cube plus x. Now we know that cos mod x is simply cos x, as cos minus x is cos x and cos plus x is also cos x. So we don't have a problem with this first function, so it will be simply this a cos x cube minus x, and this is b mod x and sine, and here we'll take mod x common, and then it will be mod of x square plus 1, which is positive, so it will be this x square plus 1. So the only problem that we have here is with this mod x function, and there will be at x equal to 0. So we just have to check differentiability of this function at x equals 0. Now when x is 0, mod of x is not differentiable, sine mod of x is not differentiable, but both of them, they have same root. This is not differentiable at 0 and this is not differentiable at 0. So essentially these two factors, they'll cancel out, and fx, it will be differentiable at x equal to 0. Another way of doing this can be, we can split it in two parts. If x is less than 0, it will be this minus x, and this will also be minus x, so it will be simply bx into sine x into x square plus 1, and if x is greater than or equal to 0, it will be bx into sine x into x square plus 1. So this function will be same whether we take x less than 0 or x greater than or equal to 0. So in both these cases, this function fx will be simply a cos x cube minus x plus bx sine x cube plus x, and this function, it is composition and product of all continuous and differentiable functions. So it will be continuous and differentiable in x belongs to R. So it is differentiable at x equal to 0, it is differentiable at x equal to 1, irrespective of values of a and b. So the correct options are a and b. Now here the question is, we are given this function f, which is defined from minus half to 2. It is given as fx equals greatest integer function of x square minus 3, and gx is mod of x into fx plus mod of 4x minus 7 into fx, then which of the following is or are true. Now if we look at this fx, it will be this greatest integer function of x square minus 3, and it is defined between minus 1 by 2 and 2. Now within this interval, if we look at integral values of x square will be integer if x is 0, 1, root 2, root 3 and 2. Now out of this, if we look at this x equal to 0, then since this is x square, so this minus h square will be 0 and plus h square will also be 0. It will be continuous at x equal to 0, and other than that, it won't be continuous. So this fx, it is discontinuous at exactly 4 values, 1, root 2, root 3 and 2. So that means option B is correct and option A is incorrect. Now if we look at this gx is mod of x, we'll take this fx common plus mod of 4x minus 7 into fx. Now mod x, it is not differentiable at 0. Now this is not differentiable at x equals 7 by 4, and fx is not differentiable at 1, root 2, root 3 and 2. Now here we are checking this differentiability in open interval minus 1 by 2 and 2. So we'll discard this 2. Now we have differentiability at 0 and differentiability at 7 by 4. And we have this fx multiplied to it. So at these points we have to check whether this fx will be 0 or non-zero. If at 0 or 7 by 4 fx is 0, then at that point this function will become differentiable. Now if we take x as 0, fx, it will be minus 3. That means it is non-zero. So at x equal to 0, this function is not differentiable. Now at x equal to 7 by 4, if we take f 7 by 4, this value will be 49 by 16, and 49 by 16 is 3 point something. So it will be this 3 minus 3, which is 0. So at x equal to 7 by 4, this function fx, it is going to be 0. So this function, it won't be non-differentiable at 7 by 4. So the only points where this function is not differentiable is x equals 0, 1, root 2 and root 3. So there are exactly 4 points. So g is not differentiable at 4 points in minus half to 2. And that's your options B and C. Now the question is, let x be greatest integer less than or equal to x, then at which point the function fx equals x into cos pi x plus greatest function of x is discontinuous. Now we can write this as this x, and then it will be this cos, then pi, greatest function of x plus pi x. Now we know that cos n pi plus theta, it will be minus 1 to the power n into cos theta. So if n is multiple of 2, there will be cos theta. If n is an odd number, then it will be minus cos theta. So we can write this as minus 1 to the power greatest integer function of x into cos pi x. Now for this function, we don't have problem with x cos pi x because it is continuous and differentiable in x belongs to R. And here we have this greatest integer function, which is discontinuous and not differentiable at x belongs to z. So this function, it is discontinuous at x belongs to z. Now for this entire function, the only problem we have is with this greatest integer function of x. Now this function fx will be discontinuous at all the integral values of x, provided this other function doesn't assume the value 0 at those integers. Now if we look at this other function and we determine its zeros, this is x cos pi x and it will be equal to 0. Now this is x equal to 0 and cos pi x is pi x equals 2n plus 1 into pi by 2. So here x is 2n plus 1 divided by 2. Now this is not an integer. The only integer at which this other function is 0 is x equal to 0. So that means this function will be discontinuous for all z except 0. So it is discontinuous for all integers except 0. And that means answer is options A, C and D. Now the question is, we are given this function fx, which is x, and here we'll take 1 minus x common, and then it'll be this log x when x belongs to 0 to infinite. And then we have 3 columns and there are 4 statements in each column. We have to work out which of these statements are correct and which of them they are incorrect. Now if we find f dash x, it will be 1 and then 1 minus x into 1 by x and then minus log x. So it will be simply 1 by x minus log x. So that's your f dash x. Now if we find f double dash x, it will be minus 1 upon x square and then minus 1 upon x. Now since x is positive, f double dash x is negative. And if f double dash x is always less than 0, it means f dash x is a decreasing function. Now since f double dash x is less than 0, will be this concave graph. We have to work out this graph using some values. Now we are given points 1, e and e square. Now if we find f1, f1 will be 1, fe will be, this is e and 1 minus e, fe is 1, and fe square will be e square plus 2 into 1 minus e square, which is 2 minus e square, and that is less than 0. Now this function f, it is continuous and differentiable. Then from Rowley's theorem we can say there exists a point c in the interval 1 to e where f dash c is 0. So it'll have a maxima between 1 and e, and at e square this value it will be negative. So this graph, it should be drawn like that. Now we'll work out values at 0 and infinity. Now if we take this limit x tends to 0 positive fx, it will be this limit x tends to 0 positive, and this is x plus 1 minus x into log x. Now this is 0, this is 1 into log 0, and log 0 approaches minus infinite. So this graph, it starts from minus infinite, and limit x tends to infinite fx, it will be this limit x tends to infinite x plus 1 minus x into log x. Now we have to work this limit out, and for this what we'll do is we let x as 1 upon t. So it'll be this limit t tends to 0 positive, and here it will be this 1 upon t, and this is 1 minus 1 upon t and log 1 upon t. So we can simplify this as limit t tends to 0 positive, we'll take t common, and here will be this 1 plus, and it will be 1 minus t into log t. Now we'll find its limit. Now this is log 0 is minus infinite upon 0 is not an indeterminate form but minus infinite. So at infinite it will be this minus infinity. Now we'll draw this approximate graph. It'll start from minus infinite, it'll take its maximum somewhere between 1 and e, and then at infinity it'll be again minus infinity. So here we'll have this point 1, and then e, it'll be this e square, and we'll have a point of local maxima in between 1 and e. Now we'll start evaluating these statements. Now fx is 0 for sum 1 and e square. Now between 1 and e square there is this one root, that means the statement 1 is correct. F dash x is 0 for sum 1 and e, this is Rowley's theorem. F dash x is 0 for sum x belongs to 0 to 1. F dash x is not 0 because there is neither maxima nor minima between 0 and 1. So this statement 3 is incorrect, and f double dash x is equal to 0. Now f double dash x, it is always negative. So that means this statement 4 is also incorrect. Now limit x tends to infinite fx, it is not 0, it is minus infinite. This we have already worked out. Now limit x tends to infinite f dash x. Now if we look at this f dash x, and if we take this limit x tends to infinite, 1 upon infinite is 0, and then minus log infinite is infinite. So we'll approach minus infinity, and limit x tends to infinite f double dash x. Now 1 upon infinite is 0, this is also 0. That means this limit is also correct. Now f is increasing on 0 to 1, correct. Decreasing on e to e square, that's also correct. Now f dash x, it is a decreasing function. So that means this statement s is correct. Now we need to choose the correct combinations. Now which of the following options is the only correct combination? And the first one correct is 1 and 2. So this A is incorrect, C is incorrect. So here we have 1 and 2. And the second and third, they are both correct. And then from R and S, S is correct. So this is your option D. Now the next one is which is the only correct combination? Now third and fourth incorrect. First and 2 correct. Now here first is incorrect. So the correct combination is this D. And the next one is which of the following is the only incorrect combination? Now this is 1, 2 and this is 2, 3. So this 3, it is not defined. Here 1 is not defined, and here r is not defined. So this again is this option D. So for all 3 of them, the correct option is D. Now the question is, for every twice differentiable function f from r to minus 2 to 2, and we are given this condition that f0 square plus f dash 0 square, and it is equal to 85, which of the following statements is or are true? Now we know that codomain for this function is from minus 2 to 2. That means any value of fx will lie between minus 2 and plus 2. Now here in this case, f dash 0 is not equal to 0. And if f dash 0 is not equal to 0, then it will be either increasing or decreasing in the neighborhood of 0. So we'll always have this small interval from minus delta to plus delta, where this function will be a 1-1 function. So that means this statement 1 is always correct. Now the next one is, there exists x0 in the interval minus 4 to 0 such that mod of fx0 will always be less than or equal to 1. Now what we'll do is, we'll apply Lagrange's mean value theorem in this interval. There will be some x0 in minus 4 to 0 such that f dash x0 will be equal to f0 minus f minus 4 upon 4, and we take this mod sign. Now we know that minimum value of fx is minus 2 and maximum value is plus 2. So the maximum value of f0 minus f minus 4 will be 4. So it will always be less than or equal to 1. That means the statement B is also correct. Now this third one, it is limit x tends to infinite fx, it is equal to 1. This may not always be true. So we have this bounded function. If we can choose this bounded function fx as sum 2 sine ax, then it will satisfy all these conditions. And if we take this x tends to infinite, it will be this oscillating value from minus 2 to plus 2. And here we can also change this amplitude. We can take any value between 0 to 2. So this option C, it is not always correct. Now this D is, there exists alpha in minus 4 to 4 such that f alpha plus f double dash alpha is 0 and f dash alpha is unequal to 0. Now this option, it is the trickiest one. Now for this fourth one, what we'll do is, we'll assume a function gx, and we let this gx as fx square plus f dash x square. Now if we find g dash x, then g dash x will be 2fx into f dash x, and here it will be 2f dash x into f double dash x. Now we'll take 2f dash x common, and then we'll have fx plus f double dash x. Now if we look at g0, g0 will be f0 square plus f dash 0 square, and which is given as 85. Now what we'll do is, we'll consider two separate intervals. First interval when x lies between minus 4 and 0, and second interval where x lies between 0 and 4. Then from this statement B, we can say there exists some point x0 which lies between minus 4 and 0 such that mod of f dash x0 will be less than or equal to 1. In the same way, we can prove it from 0 to 4 also. So here we'll get some x1 lying between 0 and 4 such that f dash x1, it is less than or equal to 1. Now if f dash x0 is less than or equal to 1, we can write f dash x0 square will also be less than or equal to 1. Then in that case, this gx, it will always be less than or equal to, now maximum value of fx is 2, so it will be this 4 plus 1, and there will be 5. So Gx0, it is less than or equal to 5, and Gx1 is also less than or equal to 5. Now, if we look at this interval between x0 and x1, which lies between -4 and +4, this function will take some value which is less than 5, and it'll end at value which again is less than 5, and at 0 this value is 85. So this function, it will increase and decrease in some way, and then this value is going to come back to this lowest value. Now, since this function is continuous and differentiable, there exists at least one point alpha in the interval x0 and x1 where g dash alpha, it is equal to 0. Since this alpha belongs to x0, x1, it will also belong to -4 and 4, and then g dash alpha equals 0 means twice f dash alpha into f alpha plus f double dash alpha will be equal to 0. Now f dash alpha, it cannot be 0. Now in this case, this value at alpha will be maximum, so this g alpha will be f alpha square plus f dash alpha square, and it should be greater than or equal to 85. Now if f dash alpha is 0, f alpha should be under root 85, but it cannot take the value greater than 2. So that means this f dash alpha, it can never be 0. So the only condition that we'll get here is f alpha plus f double dash alpha, it must be equal to 0. That means this option D is also correct. So the correct options are A, B and D. Now here the question is, we are given this differentiable function such that f0 is 1, and it says f x plus y, it is equal to fx into f dash y plus f dash x into fy. Then we need to find the value of log f4 to the base e. Now if we find f dash x, we can write this as this limit h tends to 0 fx plus h minus fx upon h, and then it will be this limit h tends to 0. Now we can write this as fx f dash h plus f dash x fh minus fx whole divided by h. Now it says fx is a differentiable function, and fx will be differentiable if it is 0 upon 0 indeterminate form, and it will be indeterminate form if fx into f dash 0 plus f dash x into f0 minus fx, it should be 0 for all x in the question. Now we already know the value of f0, we need to find the value of f dash 0, and for this what we'll do is, in this equation we'll put both x and y as 0, so it will be this f0, so this is f0 which is 1, and f0 is 1, it will be this f dash 0 plus this is f dash 0, and f0 is again 1, so value of f dash 0 is 1 by 2, and we put this value, we get fx by 2 plus f dash x minus fx equals 0, or f dash x equals fx by 2. Now we have to solve this differential equation. We write this as f dash x upon fx, and it will be equal to 1 by 2. Now if we integrate, we'll write log fx, and it will be equal to 1 by 2 x plus c. Now we take antilog, it will be this fx e to the power c into e to the power x by 2. Now when x is 0, y is 1, so it will be this 1 e to the power c into 1, so value of e to the power c is 1. So from here we can say value of fx is e to the power of x by 2. Now if we find f4, f4 is e square, and log f4 it will be simply 2. And that is the answer to this question. Now here we are given 4 functions f1, f2, f3 and f4, and we have to match them. Now this f1 is sine under root of 1 minus e to the power of minus x square. Now we know that e to the power of minus x square, it will be greater than 0 and less than or equal to 1. So 1 minus e to the power minus x square will be greater than or equal to 0. And at this value, all these functions, they are defined. So this f1x, it is continuous. But if we find f1 dash x, it will be cos under root 1 minus e to the power minus x square, and it will be 2 into under root of 1 minus e to the power minus x square minus e to the power minus x square into 2x. Now when x is 0, this denominator, it does not exist. So it is not differentiable at x equal to 0. So this function fx, it is continuous but not differentiable at 0. So this p, it matches with 2. So this p, it matches with 2. Now function f2. Now f2 is mod sin x upon tan inverse x. It is 1 when x is equal to 0. Now we take this limit x tends to 0. So this 0 negative will be minus sin x upon tan inverse x, and if we divide and multiply with x, this limit is minus 1, and limit x tends to 0 positive, it will be sin x upon tan x. Again this is plus 1. So here left hand limit is not equal to right hand limit. So this function is not continuous at x equal to 0. That means this q, it matches with 1. Now if we look at this r is this function f3, and f3 is greatest near function of sine log x plus 2 in the neighborhood of x equal to 0. This value is sine log 2. Now log 2 is 0.3010, and at this point this sign, it will lie between 0 and 1. So that means this function f3x in the neighborhood of 0 will be a constant function whose value is 0. And if it is 0, it is both continuous and differentiable. And we find its derivative, it will also be continuous. So this function, it will be differentiable at 0 and its derivative is continuous at x equals to 0. So this r, it matches with 4. And the next one is this f4x. Now for continuity, it will be this h square sine 1 by h, which is 0 into oscillating value minus 1 to 1, which is 0. So this function will be continuous. And for differentiability, it will be h sine 1 by h, which again is 0 into sine infinite minus 1 to 1. It will be 0. So it will be differentiable at x equal to 0. But if we find its derivative, it will be x square cos 1 by x minus 1 upon x square and plus 2x sine 1 by x. Now here this value will cancel. Now it will oscillate between minus 1 and plus 1, and here this value will be 0. So it's an oscillating value. So f4, it will be differentiable, but its derivative is not continuous at x equals 0. So that means this s, it matches with 3. So this correct option is this option D. Now here the question is, we are given this function fx, which is defined in this way. Now if you look at the coefficient, this is 1, 5, 10, 10, and here it is 3 and 1. So what we'll do is we'll add 2x and subtract 2x. Now this is binomial expansion of x plus 1 to the power 5. So we'll write this function fx as x plus 1 to the power 5 minus 2x. When x is less than 0, it is x square minus x plus 1. When x lies between 0 and 1, it will be 2 by 3 x cube minus 4x square plus 7x minus 8 by 3. When x lies between 1 and 3, and it is x minus 2 log x minus 2 minus x plus 10 by 3 when x is greater than or equal to 3. Now for this function, if we look at f dash x, it will be this 5 x plus 1 to the power 4 minus 2 when x is less than 0. Now this is 2x minus 1 when x lies between 0 and 1. It will be this 2x square minus 8x plus 7 when x lies between 1 and 3, and it will be log x minus 2 plus 1 minus 1, so it will cancel when x is greater than 3. Now if we put the value 0, f dash 0 negative, it will be 5 minus 2, which is 3, and f dash 0 positive, it will be minus 1. So not differentiable at 0. F dash 1 negative, it is 1, and f dash 1 positive, it will be 1. So it is differentiable at 1. And f dash 3 negative, it will be 9, 18, 18 plus 7, 25, 25 minus 1, 1, and f dash 3 positive, it will be log 1, 0, so not differentiable at 3. Now if we draw the graph of this f dash x when x is greater than 0, when x is 0, this value is minus 1, at 1 by 2, this value is 0, and at 1, this value is 1. So that is the graph 2x minus 1. Now between 1 and 3, it is this quadratic equation. Now if x is 1, this value is 1. Now it will have its minimum value at 4x minus 8 equals 0, that is at x equals to 2, and at 2 this value will be 8 plus 7 minus 16, which is minus 1. And then we have the graph of log x minus 2. Now clearly at 1 we have 2 tangents, so it is not differentiable at x equal to 1. F dash x, it has a local maximum at x equal to 1, so this option A is correct. Now C is f is on 2. Now in this interval, at minus infinite, it will be minus infinite, and at 0, this value will be 1. So it will take the value, it will take all the values between minus infinite and 0. So we do not know about its shape. What we do know is range of this function will always contain this set from minus infinite to 1. Here this function is restricted, this is also restricted. So what we'll do is we'll first find the range of this function in this interval, and then if need be, we'll solve these two. So if you look at this fourth interval, that is when the value of x is greater than or equal to 3, this phi is x minus 2 log x minus 2 minus x plus 10 by 3. We have already worked out its derivative. Its derivative is dy by dx is log x minus 2, and it is greater than or equal to 0. That means this function, it is an increasing function in this interval. So its minimum value will occur when the value of x is 3. So this y3, it will be 1, and log 1, it is 0, and then this is minus 3 plus 10 by 3. So its minimum value is 1 by 3, and now we'll find its maximum value, which will appear at infinite. So if we take this limit x tends to infinite, now this x minus 2 log x minus 2 minus x plus 10 by 3. What we'll do is we'll add 2 and subtract 2. So we'll take x minus 2 common, and it will be log x minus 2 minus 1 and then minus 2. Now we take x tends to infinite, this is infinite and this is infinite, so its maximum value is infinite. So for this function, its range is from 1 by 3 to infinite. Now in between these two, they contain all the values from minus infinite to plus infinite. So range of this function is R, and therefore this function is an onto function. Now D is f is increasing on minus infinite to 0. Now if we find this f dash, so it will be this 5x plus 1 to the power 4, it is equal to 2 when x is less than 0, and since we'll get real roots for x less than 0, this function is not strictly increasing in minus infinite to 0. So f is not increasing on minus infinite to 0. The correct options are A, B and C. And this question, we are given this function fx, and what we'll do is we'll take x minus 1 common. So we can write this as x minus 1 into x square plus sin x, and then we have this arbitrary function g, which is defined on R to R, and it is defined f into g as this product fx into gx. Now this first option is if gx is continuous at x equal to 1, then f into g is differentiable at x equal to 1. Now if g is continuous at 1, then g 1 minus h is equal to g 1 plus h, and it is equal to g1. Now we'll check left hand derivative at 1. So it will be this fg dash 1 negative. So it will be this limit h tends to 0, and this is f1 minus h g1 minus h minus f1 g1 upon minus h. Now f1 is 0, so it will be this 0. Now f1 minus h upon minus h, this is f dash 1 negative. So it is f dash 1 negative, and this is g1. And this function fx, it is differentiable. So we can write this as f dash 1 into g1. In the same way, we can write f g dash 1 positive as limit h tends to 0, and it will be f1 plus h g1 plus h. Now f1 again will be 0 upon h. Now f1 plus h upon h is again f dash 1 positive into g1. Now fx is continuous and differentiable, so it will be f dash 1 into g1, and both of them, they are equal. That means this f into g is differentiable at x equal to 1. Now this option B is if it is differentiable in 0 to 1, then g is continuous at x equal to 1. Now this may not be necessarily true, and for this what we'll do is we'll take an example which shows this may not always be true. So we'll define gx as 0 if x is equal to 1, and it is 1 when x is unequal to 1. Now if we find f g dash x, it will be simply f dash x at x equal to 1. So in this case, f g dash, it exists, but then this gx, it is not a continuous function. So from counter example, we can say this b is not necessarily true. Now C is if g is differentiable at x equal to 1, then f into g is differentiable at x equal to 1. Now this is standard result. If f is continuous differentiable, g is continuous differentiable, then their product is also continuous and differentiable. So that means this option C is correct. And D is if f into g is differentiable at x equal to 1, then g is differentiable at x equal to 1. Now this is clearly not true, because if it is discontinuous, then it is also not differentiable. So the correct options are A and C. Now the question is, we are given two functions f and g, and it says f x plus y equals fx plus fy plus fx into fy, and fx is x into gx. Now it says if limit x tends to 0, gx is 1, then which of the following statement is or are true? Now if we take this limit, this can be expressed as limit x tends to 0. Now this is fx upon x, and this is 1, and it will be 1 if it is indeterminate form. That means from here we can say value of f0, it must be equal to 0. Now if we find f dash x, it will be this limit h tends to 0, and this is f x plus h minus fx upon h, and this we can write as limit h tends to 0 fx plus fh plus fh minus fx whole divided by h. Now this fx it will cancel. We can write this f dash x as, we'll take 1 plus fx common, and it will be this limit h tends to 0 fh upon h. Now we can write this as fh minus f0, because f0 is 0 and this is nothing but this is f dash 0. So we can write this as f dash x equals 1 plus fx into f dash 0, and this is some constant, say a. Now if we look at this limit, this is 0 upon 0 form. That means we can use L'Hopital's rule. We can write f dash 0 upon 1 will be equal to 1. So f0 is 0 and f dash 0 is 1. So if we put x as 0, f dash 0 is 1, f0 is 0, and that's your f dash 0. So value of f dash 0 is simply 1. So from here we can say f dash x is simply 1 plus fx. Now we can write this as f dash x upon 1 plus fx, that is equal to 1. Now we take its integral. We can write this as log 1 plus fx, and this is equal to x plus c. Now when x is 0, fx is 0, so it will be this log 1. So value of c is 0. So from here we can say log 1 plus fx equals x, or this fx is simply e to the power x minus 1. So our function fx is e to the power x minus 1. So for this function fx is e to the power x minus 1 and gx is e to the power x minus 1 upon x. Now f is differentiable at every x belongs to R, and if we find f dash x, it is e to the power x, f dash 1 is e, and f dash 0 is 1. So c is incorrect and d is correct. Now we look at this option B, and it says if g0 equals 1, then g is differentiable at every x. Now if we take this limit x tends to 0 gx, it is standard limit, so it is 1. So this gx is continuous at x equal to 0, and if it is continuous at 0, it is continuous in x belongs to R. Now this function will be differentiable everywhere, except we have to check its differentiability at x equals 0. So if we find g dash 0 negative, it will be this limit h tends to 0, and will be e to the power minus h minus 1 upon minus h minus 1 upon minus h, and it will be this limit h tends to 0 e to the power minus h minus 1 plus h upon h square. Now this is limit h tends to 0. Now we'll use expansion of e to the power minus h. It will be 1 minus h plus h square upon 2 minus 1 plus h upon h square. Now this 1 will cancel, h will cancel. So this left hand derivative, it will be 1 by 2. Now we'll find g dash 0 positive. It will be this limit h tends to 0 e to the power h minus 1 upon h minus 1 divided by h. Now this is limit h tends to 0 e to the power h minus 1 minus h upon h square. Now again we'll use expansion. So it will be this limit h tends to 0 1 plus h square upon 2 and higher powers minus 1 minus h upon h square. Now it'll cancel. This is 1 by 2. So this function gx, it is differentiable at x equal to 0, and therefore it is differentiable in x belongs to R. So the correct options are A, B and D. Now here the question is, we are given these two functions f and g, where fx is defined as mod of 2x minus 1 plus mod of 2x plus 1, and where gx is x minus greatest integer function of x, which is basically fractional part of x. Now f is defined when x lies between minus 1 and plus 1, and so is g from minus 1 to plus 1. And f of gx is this composite function. Now suppose c is the number of points in the interval at which f of gx is not continuous, and suppose d is number of points in the interval at which f of g is not differentiable, then find the value of c plus d. Now basically f of gx is two times fraction part of x minus 1 plus mod of 2 times fraction part of x plus 1. Now we clearly know that fractional part x function, it is periodic function with period 1. So what we'll do is we'll try and find this function when x lies between 0 and 1. Now when x lies between 0 and 1, then basically fractional part of x is simply x. So in that case, this f of gx will be same as fx, which is mod of 2x minus 1 plus mod of 2x plus 1. Now if we draw this graph between 0 and 1, now at 0 this value will be 2. So at 0 this value is 2 and 2 is included. Now at 1 by 2 we have this value as 0, and here this value will be 2, and at 1 this value is going to be 4. So that is the graph of f of gx in 0 to 1, and since it is a periodic function, in between minus 1 and 0 we'll repeat the same graph. And this point is minus 1 by 2 and this point is plus 1 by 2. Now number of points in open interval minus 1 to 1 where this function is discontinuous, it is discontinuous only at x equal to 0. So basically value of c is 1, and the number of points at which this is not differentiable is 1, 2 and 3. So value of d is 3. Now we need to find the value of c plus d. The value of c plus d is simply 4, and that is the answer to this question. Now here we are given three functions f, g and h, and we need to find which of these functions are differentiable at x equals to 0. Now if we look at this fx, it is going to be continuous at 0 because it is 0 into sine infinite, which is oscillating value from minus 1 to 1, it is 0. But it won't be differentiable because we know that once we write f dash 0, it will be this limit h tends to 0 and then h sine 1 upon h minus 0 upon h. In this case, it will be an oscillating limit from minus 1 to plus 1. That means this fx is not differentiable at x equal to 0. Now, if we look at this g, in g we have this x square. So for continuity, it will be 0 into oscillating value minus 1 to 1, which is 0. And for differentiability also, it will be this limit h tends to 0, h square sine 1 by h minus 0 upon h. Now this h and h will cancel. Now here this is 0 into oscillating value minus 1 to 1, which is 0. So in this case, both left hand derivative and right hand derivative, they'll be 0. So this function gx, it will be differentiable. And if we look at this hx, which is simply mod of x cube, and we can write this as minus x cube when x is less than 0 and plus x cube when x is greater than or equal to 0. Now h0 negative is 0 and h0 positive is h0 and it is 0. So this function is continuous, and if we write h dash x, it will be simply minus 3x square when x is less than 0. It is 3x square when x is greater than 0. Now basically h dash 0 negative, it is 0, and h dash 0 positive is also 0. So that means of these three, gx and hx, they are differentiable, and that's your option C. Now here the question is, we are given this function fx, which is limit n tends to infinite and then log, and we have this series which is under root of e to the power cos x into under root of e to the power 3 cos x, and will continue up to under root of e to the power 2n plus 1 cos x, and then we have defined this gx as 1 by 3 fx greatest near function. Now we need to find number of points at which gx is discontinuous. Now first we'll simplify this function fx. Now we can write this function fx as this limit n tends to infinite, this is log, and this is e to the power cos x by 2. This is e to the power 3 cos x by 2 square. Will continue up to, and this is e to the power 2n plus 1 cos x 2 to the power of n plus 1. Now we can write this as this limit n tends to infinite, this is log, and this is e to the power, we'll take cos x common, and then it will be this AGP 1 by 2 3 by 2 square up to 2n plus 1 upon 2 to the power of n plus 1. Now this log and e will cancel, so it will be this limit n tends to infinite cos x, and this is 1 by 2 3 by 2 square 5 by 2 cube, and since this is n tends to infinite, that means number of terms in the sequence is infinite. So we have to find sum of this infinite AGP. Now if we write this sum as s, now this is 1 by 2 3 by 2 square 5 by 2 cube up to infinite, and then again we write this s leaving one term, so it will be 3 by 2 square, and then we'll multiply it with its common ratio. Now we subtract it, we can write s by 2, and it will be this 1 by 2. Now this is 2 upon 2 square, so it will be this 1 by 2, then 1 upon 2 square 1 upon 2 cube up to infinite. Now this is a geometric progression, so this is s by 2, and it is 1 by 2 plus a upon 1 minus r, so it will be this 3 by 2, value of s is simply 3. So basically this fx is 3 cos x. Now this gx is defined as greatest new function of 1 by 3 fx, so it will be this 1 by 3 into 3 cos x, which is greatest near function of cos x. Now we need to find number of points at which this gx is discontinuous in 0 to 2 pi. Now we'll draw the graph of get a function of cos x. Now that's the graph of cos x. Now this is 1, 0 and minus 1. We'll draw horizontal lines at integer points. We'll mark these points. Now this is 0. Here this point is pi by 2. This is pi. This is 3 pi by 2. And here we have this 2 pi. We'll mark these points. Between 0 to pi by 2, it lies between 0 and 1. So it will be this value. Here it is going to be this value. And here we have this value. So the number of points at which this function is discontinuous is, now this function is discontinuous at x equal to 0, at x equals pi by 2, at 3 pi by 2, and at 2 pi. So number of points where this function is discontinuous is simply 4. So answer to this question is 4. Now here the question is, we are given this function fx as signum of x minus 2 square plus k square for x belongs to R. If fx is discontinuous at exactly one point, then the value of tan inverse k plus cos inverse k plus cosec inverse 2k minus 1 is equal to m pi by 2, where m is a whole number. Find the value of m. Now we know that signum function is discontinuous at all points where this gx is 0. So that means it will be discontinuous if this x minus 2 square plus k square, it is equal to 0. If we consider this first case, when k is unequal to 0, in that case x minus 2 square plus k square, it will always be greater than 0. In that case, this fx will be 1, which is not discontinuous at any point. So clearly we must have k equals 0. If we take k equals 0, then we have x minus 2 whole square equals to 0. Then we get only one point, and that is x equal to 2. Now this function is discontinuous at x equal to 2. So basically value of k, it must be 0. And if k is 0, tan inverse 0 is 0. Cos inverse 0 is pi by 2. And cosec inverse minus 1 is minus pi by 2. And which is 0. So clearly value of m in this case must be 0. And that is the answer to this question. Now here the question is, examine the differentiability of this function fx, which is mod x plus mod x minus 1 plus mod of x minus 2. Now for this question we can see that it is a sum of linear functions of modulus functions. So whatever the interval, it is just going to be a line segment. So what we'll do is we'll start drawing this graph. Now we have three critical points, 0, 1 and 2. So we'll find the value at 0. If x is 0, this value is 3. If x is 1, this value is 2. And if x is 2, this value is 3. Now if we put x as minus 1, we'll get this as 1 plus 2 plus minus 3, we'll get this as plus 6. So it will be this plus 6, and here also at 3, it will be this plus 6. Now if we join these points, that is the graph of this function. Now this function is not differentiable at 0, 1 and 2. So it is continuous in x belongs to R, but not differentiable at x equal to 0, 1 and 2. Now here the question is, we are given this function fx, which is defined as greatest new function of x square minus greater function of x square. That is discontinuous at, we need to talk just at integer points. So let us say we are talking about x equals a, where a is an integer. Now if we look at its left hand limit, there will be this f a negative. We can write this as limit x tends to a negative, and this is greater function of x whole square minus greater function of x square. Now what we'll do is we'll let x as a minus h. So it will be this limit h tends to 0 positive, and here it will be greater function of a minus h square minus greatest greater function of a minus h whole square. Now greater function of a minus h is a minus 1. So it will be this a minus 1 whole square minus this limit h tends to 0, and here it is a square minus 2ah plus h square. Now h is nearly 0. So basically this h, it is greater than h square. So this minus term, it takes over. So this value will be little less than a square. So its greatest linear function will be simply a square minus 1. Now if we simplify this, it will be a square plus 1 minus 2a minus a square plus 1. Now here a square will cancel. So it is simply 2 into 1 minus a. Now we'll find its right hand limit. Now for right hand limit, will be fa positive, and we'll let x as a plus h. So we'll write it directly. Limit h tends to 0 positive. Now this is a plus h square minus, and this is a plus h square get a function. Now get a function of a plus h square is simply a square and then minus. This is limit h tends to 0, and it will be this a square plus 2ah plus h square. Now both h and h square, they are very small. So this is a square plus something. So its greatest linear function will be simply a square. So we can write this as a square minus a square, which is 0. So for any integer, fa negative will be 2 into 1 minus a, and fa positive, it will be 0. And if we look at this fa will also be 0. Now clearly they are equal if 2 into 1 minus a is equal to 0. That is, if a is equal to 1. So if a is 1, then they are continuous. And if a is unequal to 1, that means at all other integer points, they will be discontinuous. So answer to this question is, it is discontinuous at all integers except 1, and that's your option D. Now here the question is, we are given this function fx, which is defined from 2n to 2n plus 1 and 2n minus 1 to 2n for all integers. If f is continuous, then which of the following holds for all n? Now first we'll look for continuity at 2n. At f2n, we have this equality sign. So f2n will be equal to f2n positive, and that is the definition. So it will be this an plus, and x here is 2n. So it will be this sign 2n pi. And if we look at f2n negative, here we have this definition. So it will be this bn plus cos 2n pi, and this function is continuous. So we'll equate them. So we'll get an. Now sine 2n pi is 0, and it is equal to bn, and plus cos 2n pi. Cos 2n pi is 1. So the first result that we have is an minus bn. It is equal to 1, and that's your option B. Now next we have to check its continuity at odd number. Now problem here is, here we have 2n minus 1 and 2n plus 1. So what we'll do is, in this first definition, we'll replace n with n minus 1. Then we can write this as an minus 1 plus sine pi x if x belongs to 2n minus 1 to 2n minus 1, and here it will be this bn plus cos pi x when x belongs to 2n minus 1 to 2n. Now we can write limits for 2n minus 1. So f 2n minus 1 negative, it will be equal to f 2n minus 1. It will be this an minus 1 plus sine 2n minus 1 pi, and here for f 2n minus 1 positive, it will be this definition, which is bn plus cos 2n minus 1 pi. Now this is an minus 1. Now sine 2n minus 1 pi is 0. This is bn, and plus cos 2n minus 1 pi is cos pi, and which is minus 1. So it will be an minus 1 minus bn. It must be equal to minus 1, and that's your option D. So the answer to this question is options B and D. Now here the questions, we are given this function fx, which is 1 by 2 x minus 1 on the interval 0 to pi. Then we have to find discontinuity of 1 by fx. Now if we look at 1 by fx, it will be 2 upon x minus 2. Now this function, it is discontinuous at x equal to 2. So it will be discontinuous at x equals 2. Now if we look at 10 fx, then we're given that x lies between 0 to pi. Now we divide it with 2, then it will be 0, and then x by 2 and be less than equal to pi by 2. And if we subtract 1, then we'll get minus 1, and it will be x by 2 minus 1, and this is pi by 2 minus 1. Now in this interval, from minus 1 to pi by 2 minus 1, pi by 2 minus 1 is nearly 0.54. So if we look at the graph of 10x, now this is minus 1 and this is nearly 0.54. In this interval, 10x is continuous. So basically 10 fx will be continuous in this interval. So answer to this question is this option D, 10 fx is continuous but 1 by fx is not continuous. Now the question is which of the following functions are continuous on 0 to pi. Now first one is 10x. Now we clearly know that 10x is discontinuous at x equal to pi by 2. That means this option A is incorrect. Now option B is integral of 0 to x t sine 1 upon t dt. Now this function t sine 1 upon t, it is continuous in 0 to pi, and integral of a continuous function is also a continuous function. So this option B, it is correct. Now for this third function, if we look at 3 pi by 4 negative, it is 1. It is also equal to f 3 pi by 4 since equality is there, and f 3 pi by 4 positive will be this 2 sine 2 by 9, and x here is 3 pi by 4. Now this is 2 and this is 3, so it will be sine pi by 6, and sine pi by 6 is 1 by 2, 2 into 1 by 2 is 1. So this option C is also correct. And if we look at this fourth function, then f pi by 2 equals f pi by 2 negative, and it will be this pi by 2 and sine pi by 2 is 1, and f pi by 2 positive, it will be pi by 2 and sine 3 pi by 2, and sine 3 pi by 2 is minus 1. So it will be discontinuous. So the functions which are continuous are the functions in this option B and C. Now here the question is, we are given this function fx, which is x cos 1 by x when x is greater than or equal to 1. Now which of the following options is or are correct? Now first we will find f dash x. Now f dash x will be this x, and derivative cos is minus sine 1 by x into minus 1 upon x square and plus cos 1 by x. Now here x and x will cancel, so it will be equal to 1 by x sine 1 by x plus cos 1 by x. Now we look at this option B. So if we take this limit x tends to infinite, f dash x, it will be 1 by infinite, which is 0, and plus, now this is cos 0 is 1, so this limit is 1, that means this option B is correct. Now we'll differentiate this one more time. We'll get f double dash x as 1 by x cos 1 by x into minus 1 upon x square plus sine 1 by x into minus 1 upon x square, and plus this is minus sine 1 by x and then minus 1 upon x square. Now I'll cancel. So this f double dash x is minus 1 upon x cube cos 1 by x. Now when x is greater than or equal to 1, then 1 upon x will be less than or equal to 1, and this is greater than 0. Now 1 is less than pi by 2, and 0 to pi by 2, this cos x, it is positive. X is greater than 1, this is positive, and we have this negative sign. So that means f double dash x is less than 0. And if f double dash x is less than 0, that means f dash x is strictly decreasing in the interval 1 to infinite. That means this option D is also correct. Now we'll try and apply Lagrange's mean value theorem for this function in the interval x to x plus 2. We can write fx plus 2 minus fx upon x plus 2 minus x, that is equal to sum f dash x naught, where x naught lies in the interval x to x plus 2. Now we have established that f dash x is strictly decreasing in the interval 1 to infinite. So that means any f dash x will be greater than f dash infinite, and f dash infinite we have already worked out. So any f dash x will be strictly greater than 1. So it is greater than 1. So from here we can write fx plus 2 minus fx will be greater than 2, and that means your option C is correct. So the correct options are B, C and D. And this is true for every x, because f dash x will always be strictly greater than 1 for all the values of x. Now here the question is, we are given two functions fx and gx where a and b are non-negative real numbers. Determine the composite function g of f, and if g of f is continuous for all real x, determine the values of a and b. Now for g of f, we'll draw the graph of fx. Now here a and b, they are both non-negative real numbers. So this first one is x plus a. Now this is minus a, this is 0, and if x is 0, this value is a. And then we have this mod x minus 1. Now we can start it below this graph or above this graph. It actually doesn't make a difference because definition of gx changes at x equal to 0. So we'll draw this graph. This is 1, and this is 1, this is x minus 1, and this is minus x plus 1. Now definition of gx, it changes at x is less than 0. So in this part, this definition is x plus 1, and here the definition is x minus 1 whole square plus b. And we have this point of intersection. We have this definition change here, and at 1 we'll go with this definition. So we'll start writing g of fx. Now the first one is when x is less than minus a, definition is x minus a, and it goes in this x plus 1. So it will be this x plus a plus 1. Now second one is when x lies between minus a and 0. Now here again this is x plus a, and go in x minus 1. So it will be this x plus a minus 1 whole square plus b. And then we have from 0 to 1. So if x lies between 0 and 1, this is minus x plus 1. It will go in this. So it will be this x square plus b. And x is greater than 1. Then it will be x minus 2 whole square plus b. So that is the definition of g of fx. Now it says this function is continuous. Now at minus a, left hand limit is minus a plus 1. So it will be this plus 1. And here if we put x as minus a, it will be this 1 plus b. That means value of b is 0. Now if we look at 0, at 0 negative, it will be this a minus 1 square and plus b is 0. And here it will be this 0 and plus b is also 0. So value of a must be 1. So from this we can get the value of A as 1 and value of B as 0. So if we have the value of A and B, we can write g of fx. Now this g of fx will be x plus 2 when x is less than minus 1. It will be x square when x lies between minus 1 and 0. It will be x square again when x lies between 0 and 1. So we'll take it from minus 1 to 1, and here it will be x minus 2 whole square when x is greater than or equal to 1. Now we already know this g of fx, it is continuous. We have to find whether this function is differentiable or not differentiable. Now if we find its derivative, it will be this one when x is less than minus 1. It will be this 2x between minus 1 and 1, and it will be this 2x minus 2 when x is greater than 1. Now f dash minus 1 negative is 1 and f dash minus 1 positive, it will be minus 2. F dash 1 negative is 2 and f dash 1 positive is minus 2. So it is not differentiable at x equals minus 1 and 1. And they have asked for its differentiability at x equal to 0. And since we have this x square definition, when x is 0, this function is differentiable at x equals 0. Now here the question is, if f is defined from R to R and it is differentiable at C belongs to R and fc is 0, it says if gx it is equal to mod of fx, then we have to discuss differentiability of gx. Now if we look at g dash c negative, it will be this limit h tends to 0 positive mod of f c minus h minus mod of fc upon minus h. Now we are given that fc is 0. So we can write this as this limit h tends to 0 positive mod of f c minus h upon minus h, or we can write this as this limit h tends to 0 minus, and we'll take this h inside, so it will be this f c minus h and then minus fc, because fc is 0, we can just add or subtract fc upon h. Now this is left hand derivative at c, so this is equal to minus mod of f dash c. And the same way, if we write g dash c positive, it will be this limit h tends to 0 positive mod of f c plus h minus mod of fc upon plus h. Now this is 0, we can write this as limit h tends to 0 mod of f c plus h minus fc upon h, which is mod of f dash c. Now this function is differentiable, then both these values, they must be equal. So minus mod of f dash c must be equal to mod of f dash c, and it is only possible if f dash c is 0. So this gx will be differentiable if f dash c is 0, and that's your option D. Now here the question is, we are given this function fx, which is 15 minus mod of x minus 10. Then we need to find set of all values of x, for which gx, which is f of fx, it is not differentiable. Now gx will be 15 minus mod of fx minus 10. So it will be this 15 minus, and fx is 15 minus x minus 10 minus 10. So it will be this 15 minus 5 minus mod of x minus 10. Now mod x function, it is not differentiable at x equals to 10, and it will also not differentiable at 5 minus mod of x minus 10 equals 0, that is x minus 10 equals plus or minus 5. So at x equal to 5 and at x equal to 15. So not differentiable at 5, 10 and 15, and that's your option B. Now in the questions we are given this function fx, which is defined as minus 1 when x lies between minus 2 and 0, and this is x square minus 1 when x lies between 0 and 2. And then we have this function gx, which is mod of fx plus f mod x. Then in the interval minus 2 to 2, g is what? Now first we'll draw the graph of fx between minus 2 and 0. This is minus 1, not included at 0. And between 0 and 2, this is x square minus 1. So this is x square minus 1. So that is the graph. So this is minus 1 and this is x square minus 1, and this point here it is 1. So this is y equals fx. Now if we take the transformation of y equals mod fx, then we'll reflect the graph about x-axis in the upper direction, and then we'll erase the graph from third and fourth quadrant. So it'll be this graph, and here it will be inverted like this. So between minus 2 and 0, this is 1. Here it will be x square minus 1, and here it will be minus x square minus 1. So that is the graph and definition of mod fx. Now we'll draw f mod x. Now for f mod x, we erase the graph from second and third quadrant, and then we take reflection of right or left. So on the right we have this x square minus 1, and if we take its reflection on the left, it will be x square minus 1. So f mod x is simply x square minus 1. Now we can write the definition of gx. When x is less than 0, this is 1 and this is x square minus 1. So if we add them, it will be this x square. Now between 0 and 1, this is x square minus 1 and this is minus x square minus 1. So it will cancel, it will be 0. And when x is greater than or equal to 1, it will be x square minus 1 plus x square minus 1. It will be 2x square minus 1. Now since both the functions, they are continuous, this function gx, it is continuous and minus 2 to 2. Now we have to check its differentiability. Now we find g dash x, it will be 2x when x is less than 0, and it will be 0 between 0 and 1, and it is 4x when x is greater than 1. Now at 0, it is differentiable because 0 negative is 0 and 0 positive is 0. So it is differentiable at x equal to 0, and at 1, its left hand derivative is 0 and right hand derivative is 4. Not differentiable at x equal to 1. So answer is not differentiable at 1 point, and that's your option A. Now in the questions, we are given this function fx, which is defined as maximum of minus mod x and minus under root of 1 minus x square. Now if we look at this graph, which is y equals minus 1 minus x square, it is x square plus y square equals to 1, and this minus sign it represents, we are talking about a semicircle which lies below x-axis. So this is the graph of minus under root 1 minus x square when x lies between minus 1 and plus 1. Now we have to draw the graph of y equals minus mod x. Now this is the graph of y equals minus mod x. Now we have to choose maximum of the two. Maximum of the two. Now in between minus 2 and this point, maximum is this graph. Now between 0 and this is maximum. And here again, this is maximum. Now it is not differentiable at these 3 points. So f is not differentiable at 3 elements, and that's your option A. Now here the question is, we are given this function fx, which is maximum of mod x and x square when mod x is less than or equal to 2, and it is 8 minus 2 mod x when mod x lies between 2 and 4. Now we need to find set of points in the interval minus 4 to 4 at which f is not differentiable. Now we'll draw this graph, and we have to draw it between minus 4 to plus 4. Now in between minus 2 and plus 2, it is maximum of mod x and x square. Now this is mod x, and then we have x square. They'll intersect at minus 1 and plus 1. Now we have to choose maximum of the two. So we'll choose this function, this, and this. Now at 2, this value is 4. Now when x lies between 2 and 4, it is 8 minus 2x. So if we put x is 2, it will be this 4, and at 4 it will be 0. So it will be this straight line, and here also it will be this straight line. Now it is not differentiable at minus 2, minus 1, 0, plus 1 and plus 2. And that's your option A. Now the question is, we are given this function fx, which is defined as mod of fx minus fy, that is less than or equal to 2 times mod of x minus y to the power 3 by 2. Now we can rearrange this as fx minus fy upon x minus y, and it is less than or equal to x minus y to the power 1 by 2. And what we'll do is, we'll take this limit y tends to x both sides. Now this is f dash x will be less than or equal to 0. Now modulus cannot be negative. So from here, the only condition that we'll get is f dash x equals to 0. That means this fx, it is a constant function. Now if it is constant, its value is same at all points. So if f0 is 1, this fx is simply 1. So we have this constant function fx, which is 1. Now we have to find this integral, which is from 0 to 1, and then f square x, and this is simply 1 dx, and 1 dx is 1, and that's your option C. Now here the question is, we are given this set S, which contains all the points with this function fx, which is mod of x minus pi e to the power mod x minus 1 and sine mod x is not differentiable. Now mod of x minus pi, it is not differentiable at pi. E to the power mod x, it is not differentiable at x equal to 0, and sine mod x, it is also not differentiable at x equal to 0. Now at x equal to pi, this function is not differentiable. But if we look at this sine pi is 0. So that means left hand derivative will be 0 and right hand derivative will be 0. So that means this function is differentiable at x equal to pi. Now at x equal to 0, it is not differentiable, but then this sine 0 will be 0. So here also we'll have equal left hand derivative and right hand derivative. So this function, it will be differentiable at x equal to 0. And same for this, if we take differentiability for this expression e to the power 0 minus 1 will be 0, thereby making left hand derivative and right hand derivative is equal. So it is differentiable at x equal to 0. So this function is differentiable in x belongs to R, and therefore this set is an empty set, and that's your option A. Now the question is, we are given this function fx, which is mod of log 2 minus sin x, and this gx is f of fx. Then we have to check for differentiability of g at 0 and g dash 0. Now when x tends to 0, sin x is nearly 0. In that case, log 2 minus sin x, it will be greater than 0. That means this fx will be simply log 2 minus sin x. So this gx, it will be f of fx, which is log 2 minus sin fx. And we differentiate this, we can write g dash x as minus, now this is cos fx into f dash x, and f dash x is minus cos x. So we can write g dash x as cos x into cos fx. Now if we put x as 0, we'll get g dash 0 equal, now cos 0 is 1 and this is cos f0, and f0 is simply log 2. So g dash 0 is cos log 2, and that's your option B. Now the question is, we are given this function fx, which is x square mod of cos pi x when x is unequal to 0, and it is 0 when x is 0. Now we need to check its differentiability at both x equal to 0 and x equals 2. Now at x equal to 0, its limits will be 0 into cos infinite, and cos infinite is oscillating value, and since we have this mod between 0 to 1, 0 into anything finite is 0. So this function is continuous at x equal to 0, and this function is also continuous at x equal to 2, because this x square and mod cos, they are all continuous functions. Now we'll check differentiability at 0. Now f dash 0 negative will be this limit h tends to 0 positive. Now f0 minus h will be this h square and then mod cos pi by minus h upon minus h. Now I'll cancel. Now this again is 0 into cos infinite, which is 0, and the same way f dash 0 positive will be this limit h tends to 0 positive, and this is h square mod cos pi by h upon h. Now this h and h will cancel. This again is 0 into cos infinite, which is 0. So this function is differentiable at x equals 0. Now we have to check its differentiability at x equals 2. Now if we look at f2 will be 2 square mod cos pi by 2 and cos 90 is 0. Now if we look at its left hand derivative, f dash 2 negative, it will be this limit h tends to 0, 2 minus h whole square mod of cos pi upon 2 minus h minus 0 upon minus h. Now pi by 2, 2 minus h will be greater than pi by 2. That means this angle, it is in second quadrant, and in second quadrant cos is negative. So it will be this limit h tends to 0, 2 minus h whole square, and then it will be this minus cos pi upon 2 minus h upon minus h. This minus and minus will cancel. Now what we'll do is we'll write this cos theta as sin 90 minus theta. So we can write this as limit h tends to 0, 2 minus h whole square, and this is sin pi by 2 minus pi upon 2 minus h upon h. Now this is limit h tends to 0, 2 minus h square, and this is sin. Now this is 2 pi and 2 pi will cancel, so it will be this minus pi h upon 2 into 2 minus h, and here we have this h. Now what we'll do is we'll multiply and divide everything with minus pi 2 into 2 minus h. So it will be this minus pi 2 into 2 minus h. Now this is standard limit 1. Here this value will be this 4 and here it is minus pi by 4. So this left hand derivative at 2, it is minus pi. Now we'll find its right hand derivative at 2. Now we write f dash to positive, it will be this limit h tends to 0, 2 plus h mod of cos pi upon 2 plus h upon h. Now pi by 2 upon 2 plus h is less than pi by 2, so it is first quadrant. So it will be this limit h tends to 0, 2 plus h cos pi upon 2 plus h by h. Now again we'll change it in sign, so it will be this limit h tends to 0, 2 plus h, and it will be this sign pi by 2 minus pi upon 2 plus h divided by h. Now this is limit h tends to 0 and this is 2 plus h, actually it is 2 plus h square all the way, and then it will be this sine pi h upon 2 into 2 plus h. Now this is h and again we'll multiply and divide with pi upon 2 into 2 plus h. Now this is 1, this is 4 and this is pi by 4. So its right hand derivative is pi. So left hand derivative is minus pi and right hand derivative is plus pi. So that means this function is not differentiable at x equal 2. So answer to this question is differentiable at 0 but not differentiable at 2, and that's your option B. Now here the question is, we are given a differentiable function f satisfying f 1 by n equals 0 for all n greater than or equal to 1. Then which of the following is correct? Now we know that f1 is equal to f1 by 2 equals f1 by 3, and it goes on till f1 by n, where n is all natural numbers. That means as we are approaching 0, in the neighborhood of 0 there are many points which are having this value as 0, because it is given that f1 by n is 0. And since this function is continuous and differentiable, basically in the neighborhood of 0, this function fx, it will be 0, and if it is 0, then its derivative will also be 0. So f0 must be 0 and f dash 0 must also be 0, and that's your option B. Another way to look at it is, if we take this limit n tends to infinite f1 by n, and we know that this is 0, so we can write f0 equals to 0, and f dash 0 is going to be this limit h tends to 0 f h upon h. Now we'll choose this h so that it hops between 1 upon n minus 1. So in this case, this f0 will be 0. Then again, we'll end up getting the same answer. f0 is 0 and f dash 0 is 0. Now here the question is, we are given this function fx, which is 10 pi into greatest near function of x minus pi upon 1 plus greatest near function of x square. Now we know that any greatest near function, it is nothing but an integer, and then 10n pi is 0. So basically this function fx, it is a constant function whose value is 0 throughout, and if that is the case, then f dash exists for all x, and that's your option D. Now here the question is, we are given this function fx, which is x cube plus 3x plus 2, and g of fx, it is x, and h of g of gx, it is also x. Now if we replace this x with fx, we can write h g and g of fx, it is equal to fx. Now g of fx is x. So from here we can say this h of gx is actually fx. We have to find h of g3, then h of g3 will be simply f3, and f3 is 27, 27 plus 2, 29, 29 plus 9, 38. So this is 38. That means this option D is incorrect. Now again, if we replace this x with fx, we can write h of g of fx, it is equal to f of fx. Now g of fx is again x, so we can write hx as f of fx. Now if we find h0 will be f of f0. Now f0 is 2, so this is f2, and f2 is 8 plus 2, 10, 10 plus 6, 16. So this value is 16. That means this option C is correct. Now we have to find h-1. We have to differentiate this. We can write h-x as f-fx into f-x. Now f-x is 3x square plus 3. Now we need to find h-1, and h-1 is f-f1 into f-1. Now we look at f1. f1 is 6, so it will be this f-6 into f-1. Now f-1 is 6 and f-6 is 111. So this value will be 111 into 6, and is going to be 666, and that means this option B is correct. Now we have to find g-2. So we'll differentiate this. We can write g-fx into f-x, it is equal to 1. Now we need g2, and we know that f0 is 2, so we'll put x as 0. So it will be this g-f0 into f-0, it is equal to 1. Now this is g- and f0. f0 is 2 and f-0 is 3. It is equal to 1. So value of g-2 is 1 by 3. So the only correct options are B and C. Now here the questions. We are given this function fx, which is x square upon 4 minus 3x upon 2 plus 13 by 4 when x is less than 1, and it is mod of x minus 3. We'll actually write this as minus x minus 3 when x lies between 1 and 3, and it is x minus 3 when x is greater than or equal to 3. Now clearly it is continuous at 3 and not differentiable at x equal to 3. So it is continuous at x equal to 3 but not differentiable. We have to check its differentiability at 1. Now if we check f1 negative, it will be 1 by 4 minus 3 by 2 plus 13 by 4. There is 7 by 2 minus 3 by 2, and there will be simply 2. And f1 equals f1 positive. Here will be this minus 1 minus 3, it is 2. So it is continuous at x equals 1. Now we differentiate this. We can write x by 2 minus 3 by 2 minus 1 plus 1. This is when x is less than 1, when x lies between 1 and 3, and when x is greater than 3. So clearly it is not differentiable at 3. Now at 1, f-1 negative, it will be 1 by 2 minus 3 by 2 minus 1, and f-1 positive is also minus 1. So it is differentiable at x equal to 1. So continuous at x equal to 1, differentiable at x equal to 1, and not differentiable at x equal to 3. So the correct options are A and B. Now here the questions. We are given some functions A, B, C, D, and we have to match them with P, Q, R, and S. Now in this A, we have this function fx as x into mod x. Now we can write this as minus x square when x is less than 0, and it is plus x square when x is greater than or equal to 0. Now we can draw its graph also. Now this is minus x square, and here it is plus x square. Now this A, it matches with, it is continuous in minus 1 to 1. With B, it is differentiable, it is strictly increasing. So A matches with P, Q and R. So this A, it matches with P, Q and R. Now this B is under root of mod x. Now this is under root x, and for mod x, we'll take its reflection. Now between minus 1 and plus 1, it is continuous. So this B, it matches with P. It is not differentiable at 0. It is not strictly increasing, and S is not differentiable at least 1 point. So this B, it matches with P and S. So this B, it matches with P and S. Now this C is x plus greatest near function of x. Now between minus 1 and 0, this is x minus 1. So it will be this graph. Between 0 and 1, this is x. Now this is discontinuous, not differentiable, but strictly increasing and not differentiable at least 1 point. So this C, it matches with R and S. So this C, it matches with R and S. And finally, we have this option D, which is mod of x minus 1 plus mod of x plus 1. Now when x is greater than minus 1, this is x plus 1, and when x is less than minus 1, this is 1 minus x. So basically it is a constant function, and if it is constant, it is both continuous and differentiable. So this D, it matches with P and Q, and that is the answer to this question. Now here the question is, for this function, we need to find its left hand derivative and right hand derivative. Now we have to check its continuity. Now f0 negative, it will be this limit h tends to 0. Now this is minus h, and this is 1 plus e to the power minus 1 by h. We'll check its form. So this is 0 plus 1, and e to the power minus infinite is 0. So this is 0, and f0 positive, it will be this limit h tends to 0, and this is h upon 1 plus e to the power 1 by h. Now this is 0 upon infinity, which is again 0, and it is given that f0 is 0, so it is continuous at x equals 0. Now we'll find its left hand derivative. Now f dash 0 negative, it will be this limit h tends to 0. Now this is minus h upon 1 plus e to the power minus 1 by h minus 0 upon minus h. Now this minus h and minus h will cancel. Now this is 1 upon 1 plus 0. So its left hand derivative is 1, and we find its right hand derivative, it will be this limit h tends to 0, h upon 1 plus e to the power 1 by h minus 0 upon h. Now this h will cancel. Now this is 1 upon, and e to the power infinite is infinite, so it will be 0. So its left hand derivative is 1 and right hand derivative is 0. Now here the question is, we are given this function fx, which is x minus 1 whole square sine 1 upon x minus 1 minus mod x when x is unequal to 1, and this is minus 1 when x is equal to 1. Now this mod x, it is not differentiable at x equals to 0. This function fx will also be not differentiable at x equals 0. So we don't bother about this mod x. Now at 1, this mod x is continuous and differentiable, so we just have to focus on this part. Now f1 negative, it will be this 1 minus h square sine 1 upon minus h minus mod of 1 minus h. Now this is 0 and this is minus 1. So this is minus 1. In the same way, f1 positive will be h square sine 1 by h minus mod of 1 plus h. Now this again is 0 into oscillating value, and this again is minus 1. So it is continuous at x equal to 0. Now we'll find its differentiability at x equal to 0. Now we'll find its differentiability at 1. Now f dash 1 negative, it will be this limit h tends to 0, and f1 minus h is h square. It'll be this sine 1 by minus h, and then minus mod of 1 minus h, and then minus minus plus 1 divided by minus h. Now this is limit h tends to 0. This is minus h square sine 1 by h, and this is minus 1 plus h plus 1 upon minus h. Now this 1 and 1 will cancel. Now here it will be this limit h tends to 0, h sine 1 by h minus 1. Now this is 0 into oscillating value, which is 0. So f dash 1 negative is minus 1. Then the same way we'll find f dash 1 positive, and it will be this limit h tends to 0, h square sine 1 by h minus mod of 1 plus h plus 1 upon h, and it will be this limit h tends to 0, h square sine 1 upon h minus h upon h. Now we'll cancel this h, so this is minus 1, and it is h sine 1 upon h, which again is 0 into oscillating value. This again is minus 1. So it is differentiable at 1. So it is not differentiable at 0, but differentiable at 1. So the set of points where this function is not differentiable is x equal to 0. Now the question is, it says if function is differentiable at 0 and mod c is less than 1 by 2, find the value of a and prove that 64b square is equal to 4 minus c square. Now first we'll check its continuity. So f 0 negative, it will be b sine inverse c by 2, and f 0 positive, it will be this limit x tends to 0 e to the power ax by 2 minus 1, and here we have x, so we'll multiply and divide it with a by 2. Now this is standard limit 1, so it will be this a by 2, and we are given that f0 is 1 by 2. So if we equate them, we can write b sine inverse c by 2, it is 1 by 2, and it is equal to a by 2. From here we can say value of a is 1. Now we have to prove this other part, and for this we use differentiability. Now we differentiate this, we can write f dash x as this is b, and this is 1 upon under root of 1 minus x plus c by 2 whole square into 1 by 2 when x lies between 1 by 2 and 0. Right hand derivative at 0, which will work out in the traditional way. Now its left hand derivative will be b upon under root of 4 minus c square. Now we'll find its right hand derivative. Its right hand derivative will be f dash 0 positive, and will be this limit h tends to 0. Now f0 plus h, and f0 plus h is e to the power h by 2 minus 1 upon h minus f0, which is 1 by 2 upon h. Now we can write this as limit h tends to 0, 2 into e to the power h by 2 minus 1 minus h upon h square, and we also have this 2 here, so it will be this 2h square. Now this is limit h tends to 0. Now we'll use series expansion of e to the power x, so it will be 1 plus h by 2 plus h square by 8 minus 1 minus h upon 2h square. Now this 1 will cancel and this h will cancel, so we'll get this as limit h tends to 0. Now this is h square by 4, and this is 2h square plus higher powers. So answer to this limit is 1 by 8. So if this function is differentiable, then this left hand derivative must be equal to its right hand derivative. That means b upon under root of 4 minus c square must be equal to 1 by 8. Now we square it, we can write 64b square equals 4 minus c square. 64b square equals 4 minus c square, and which is what we need to prove in this question. Now question number 10, it says, recall that sine inverse t, which is arc sine t, is a function with domain -1 to +1 and range -π/2 to +π/2. Now it says, consider the function fx, which is sine inverse of sine x, and then we'll need to find whether these three statements, they are true or false. So what we'll do is, in this question, we'll draw the graph of sine inverse of sine x. So we have already discussed the graph of sine inverse of sine x in one of the previous videos when we were discussing graphs. So I'll put the link to that video in the description below. So we'll draw the axis. And then for sine inverse, principal value range is -π/2 and +π/2. So we'll draw -π/2 and +π/2 on both the axes. Now between -π/2 and +π/2, it will simply be x. And then we'll keep drawing these zigzag lines. So that is the graph of sine inverse of sine x. Now the first question is, the function fx is well defined for all real numbers x. The domain of this function is simply x belongs to R. So that means this function is well defined for all real numbers x, so which is true. Now the second is, the function fx is continuous wherever it is defined. So this function, it is continuous for all x belongs to R. So this is also true. Function fx is differentiable wherever it is continuous. So at these points, we know that we have two different tangents. So that means this function, it is continuous for x belongs to R, but it is not differentiable odd multiples of π/2. So that means third statement is simply false. So answer to this question is true, true, and false. I'll take up another question, and that question is, y equals greatest needle function of 2 sine x. Now here again, my basic function is y equals 2 sine x, and I'll draw this graph between x equals to 0 and x equals 2π. So I'll draw the graph of 2 sine x, and I'll draw horizontal lines at integral values of y. I'll mark their point of intersection. So this is 0, pi, and 2π. Now this is π/2, and this is 3π/2. Now when I'll put y as 1, I'll get sine x equals 1/2, which is π/6. From symmetry, I can say this is pi minus π/6, it will be 5π/6. And this one will be pi plus π/6, so there will be 7π/6. And here it will be 2π minus π/6, so there will be 11π/6. Now I'll draw horizontal lines. So between 0 and π/6, it will be 0. Then so the graph in black is actually the graph of greatest needle function of 2 sine x. And now in this graph, they may ask you to find continuity, differentiability, or area, or the value of definite integral. We can find it simply using the graph. Now in question number 19, this function f is defined as x minus 1 into minimum of x or x square when x is greater than or equal to 0, and x into minimum of x or 1/x when x is less than 0. So when x is greater than 0, if I'll draw the graph of y is equal to x and y is equal to x square, so this is y is equal to x line, and this is y is equal to x square. So between 0 and 1, the function which is minimum is x square, and between 1 and infinite, minimum function is x. So I can write this function fx as x into x minus 1 when x is greater than 1, and this is x square into x minus 1 when x lies between 0 and 1. Now when x is less than 0, I need to consider minimum of x and 1/x. So when x is less than 0, we have this 1/x, and then we have this y equals x,
and their point of intersection will be -1. So between -1 and 0, this minimum value will be 1 by x, and when x is less than -1, this minimum value will be x. So I can write this as, so between -1 and 0, in that case, minimum is 1 by x, so 1 by x into x is simply 1. And when x is less than -1, here the minimum value is simply x, so now it will be simply x squared. Now I'll need to find continuity and differentiability of this function. So if I'll put x as 1, it will be 0. At 1, here also it will be 0. So it is continuous at 1. So if I'll put x as 0, I'll get this as 0. But if I'll put x as 0 here, it is 1. So it is discontinuous at x equal to 0. Now at -1, this value is 1. And at -1, this value is again 1. So this function is continuous at all points except at x equal to 0. Now I'll differentiate this function. So if I'll find f dash x, I'll write this as 2x minus 1 when x is greater than 1, 3x square minus 2x when x lies between 0 and 1. This is 0 when x lies between -1 and 0, and this is 2x when x is less than -1. Now when x is greater than 1, so if I'll put x as 1, I'll get this value as 1. So that means right hand derivative at 1 is 1. And if I'll put x as 1 here, I'll get 3 minus 2, which is 1 again. So that means this function is differentiable at x equal to 1. Now what about 0? Now we already know this function is discontinuous at x equal to 0. Now we know that if a function is discontinuous at a point, then it is not differentiable at that point. So that means this function is not differentiable at x equal to 0. Now what about -1? So at -1, right hand derivative is 0, left hand derivative is -2. So that means it is also not differentiable at x equal to -1. So this function is not differentiable at 0 and -1. So that means answer to this question is not differentiable at exactly 2 points. Now in question number 20, we are given this function f such that, now question number 9 is, fx is maximum of cos x and x square when x lies between 0 to pi by 2. If x0 is the solution of the equation cos x equals x square, then which of the following is correct? So we'll draw the graph of cos x and x square when x lies between 0 and pi by 2. So between 0 to pi by 2, cos x is a decreasing function and x square, it is an increasing function. So this is the graph of y equals x square, and this is the graph of y equals cos x. Now these two graphs, they intersect at x0. So this point is x0. Now it says maximum of the two functions. So from 0 to x0, the maximum of the two functions is cos x. So our function fx will be simply this graph. And from x0 to pi by 2, the function is x square. So that is the graph of y equals fx. Now this graph is continuous in 0 to pi by 2. It is differentiable everywhere except at this point x0. So answer to this question is f is differentiable everywhere except at x0, and that's your option D.